In this class we are going to discuss about SR flip-flop. So as you know that flip-flops are nothing but single bit storage devices, and we are going to design so many memories and all these by using flip-flops. This is very important to know about flip-flops. So now this initial flip-flop is a SR flip-flop, that is also called as set and reset flip-flop. So here we are going to design that flip-flop, and we are going to determine the functionality. So see here, so this is SR flip-flop. So this is SR flip-flop, like this it will be. So the functionality it's having is set, we can set and reset, and we can remain as it is. So by giving a series of inputs for this. So this is SR flip-flop by using NAND gates. So here you can observe a clock pulse. Here this is clock input. You can say this is clock input for SR flip-flop. Previously for latches we are having this as latch. So we are giving some clock pulse circuit. So this is going to become as flip-flop, that's it. So up to here this is a flip-flop, actually a latch, and by giving some clock pulse like this circuitry, by just adding this circuitry, we are maintaining this as flip-flop. So here now when you saw this type of structure, everyone are going to misunderstand like Qn and Qn bar are outputs, our outputs, required outputs. Yes, those are outputs, but not our required outputs. Those are just present state of that flip-flop or latch. Present state is nothing but that is input, feedback input for our circuit. That means present state is nothing but output came from past inputs. So that is not our required input. Always you need to check for next state. Next state is nothing but by taking the reference of this present state and my present inputs. So whatever we are getting as output, that is called as next state. That next state is our required output for any sequential circuit. So now I am going to get my functionality by using truth table. I want to represent my functionality. So my inputs are S and R, set reset inputs I am giving, and here Qn is present state. This is also taken as a reference, but we do not know that present state. So because anyone given you a circuit like SR flip-flop or anything, we do not know the present state, in which state that is in, we do not know. So just we need to give input sequence, that means S and R values you need to give either 0, 1 or 1, 0 like that. It is going to give next state. That next state we need to define here. So here my SR may be either 0, 0, 0, 1 and 1, 0 and 1, 1. We do not know this present state, but we are taking as a reference to get my next state. That next state I am going to define here. So first combination I am taking, when S equal to 0, R equal to 0, what may be my next state of machine. So here I am considering my first example, that means first combination of SR is equal to 0, R equal to 0. So in this condition, in this case, if I given S equal to 0, R equal to 0 and the clock pulse, here I am taking clock pulse is on. Clock pulse is on means, so here clock is equivalent to 1. So here when clock equal to 0, I will give you after completing this, when clock is equal to 1, what you are getting. So always clock need to be 1 to trigger that flip-flop. So here 0 into 1 you are getting 0 bar, you are getting here. So 0 into 1 bar you are getting 1 here. Again here also 0 into 1 whole bar you are getting 1 here. So you just keep in mind when you got at the output of SR latch, what you are getting? Obviously you are getting no change condition, right? For SR latch by using NAND gates, you can see previous class also, when 1 1 condition you given for this latch circuit, you are getting no change condition. You can observe here 1 into Qn bar whole bar, you are getting Qn plus 1 is equivalent to Qn only. So after processing these present states to the circuit, whatever you are getting again at this port, that is called as Qn plus 1. So here Qn plus 1 is equivalent to Qn bar into 1 whole bar is equivalent to Qn only, that means no change state. So here you are getting when your clock pulse is 1 and when you are providing SR equivalent to 0 0, so here you are getting 1 1, so that will provide no change condition, that means Qn here. So that means here I am taking, Qn plus 1 is equivalent to, so this thing I am writing, so I am just processing, so 1 into Qn bar whole bar, you are getting Qn. This is my first condition. My second condition is S equal to 0 and R is equivalent to 1. So if you given S equivalent to 0 and R is equivalent to 1, then 0 into 1 whole bar, again here 1 is there, but here 1 into 1 whole bar, 1 bar will come, that means here you will get 0 in place of 1. So now when you got 1 0, then your flip-flop is going to reset. See here. So this is a latch circuit. For a latch circuit, if you given 1 0, your latch is going to reset. So you just check here. So for example, so I am taking normal port for Qn plus 1. If I want to write, then 1 into Qn bar whole bar, 1 into Qn bar whole bar. So this is equivalent to Qn you are getting. You didn't got any value. So you just checking in a complementary port, if you are getting value, then you can imply for that normal port. So I am checking Qn plus 1 bar port, that means this port output. So here 0 into Qn whole bar you are getting, 0 into Qn whole bar, this is equivalent to 0 into anything 0, 0 bar means 1. If Qn plus 1 bar is equivalent to 1, then definitely Qn plus 1 value may be complement of this, that means this may be is equivalent to 0, with reference of this value may be equivalent to 0. So finally, in case of S equal to 0, R equal to 1, you are getting reset condition of SR flip-flop. So 0, so this is called as reset condition. So now in third case, I am taking third case of SR flip-flop, S equal to 1, R equal to 0. In this case, your SR flip-flop is going to set. See here, so if S is equivalent to 1 and R equivalent to 0, what is going to happen? Reverse of this, just you are getting 0 here and you are getting 1 here. So it's nothing but you are getting complement of output also. So see here, so when you given 1 0, 1 into 1 whole bar 0 and 1 into 0 whole bar, so you are getting 1 here. So now if you given 0 1 here, what is going to happen? I am just writing here, when S equal to 1, R equal to 0, your Qn plus 1 is equivalent to, so I am taking this port 0 into Qn bar, 0 into Qn bar, Qn bar whole bar, 0 into Qn bar whole bar. So this is equivalent to 0 into anything 0, 0 bar is equivalent to 1. You got the value of Qn plus 1, then no need to go for Qn plus 1, Qn plus 1 complement. Why? Because if you know Qn plus 1, then only you can say Qn plus 1 whole bar equivalent to 0. If you got like this, that means if you are not getting value in normal port, then you need to check the complement port for any value. Sometimes for complement port also no value will come to take as reference. Then we can't do anything, you just write like this only. So here I am writing, so 1 here. So this is called as set condition of SR flip-flop. Finally, we are having fourth condition, that is S equivalent to 1 and R is equivalent to 1. So when you given S equivalent to 1 and R is equivalent to 1 in both ports. 1 into 1 whole bar you are getting 0, 1 into 1 whole bar you are getting 0. If you given 0 0 for this latch, so this is up to here, this is a latch, right. So for example, if you are giving 0 0 for this latch, then your condition is going to be undetermined, because we can't determine this state, because 0 into anything bar you are getting 1 and here also 0 into anything bar you are getting 1. For Qn plus 1 and Qn plus 1 bar you are getting same output. That means if a variable is getting same output for its complement, and for that means that is not determined. So in this case Qn plus 1 is equivalent to 0 into Qn bar whole bar you are getting, here also you are getting 1. So Qn plus 1 whole bar also 0 into Qn whole bar you are getting, that means here also you are getting 1. This condition is not possible, this is not possible. So it can be treated as indeterminate state. So I am just representing like ID, indeterminate state. So here also I am taking like this, indeterminate state. This state we are not going to take. So observe the truth table. Finally, for this circuit, if you given 0 0, then output is not going to change. If you want your circuit to be in the same state for next state also, means you need to give 0 0, that is the meaning. So if you want to reset your circuit, means you need to give 0 1 for SR flip flop. If you want to set your flip flop, means so then you need to give 1 0. So here this state is wasted, that means we are not using this state for any operation. So that means 1 1 state in SR flip flop we are not using. So this is indeterminate state, this is no change state in SR flip flop. So this is about SR flip flop by using NAND gates. In the next classes we will design remaining flip flops like D flip flop, JK flip flop. So many T flip flop like that are there. So we are going to design by using same procedure.